In this video, we're going to look at curve sketching. So to sketch the graph of a function, first of all, we need to find the points of intersection, if there are any, with the x and y axes. Then we need to find the stationary points and their nature by differentiating and equating to zero and solving. And then we need to look at the behaviour of the curve for large positive and negative values of x. So we need to look at what happens when x tends to positive and negative infinity. Then once we have all these key points, we can draw in our smooth curve connecting them all together. So in this example, we want to sketch the curve y equals x cubed minus 3x squared. So first, we want to find if there's any points of intersection with the y-axis. So at x equals 0, y is going to equal 0 cubed minus 3 times 0 squared, which equates to 0. So we have a point of intersection on our y-axis at the origin 0, 0. So that's a point of intersection on our x-axis as well. And what we're going to do is we're going to plot that in. Now at y equals 0, that's when it's going to cross our x-axis. That's the roots of this. And so x cubed minus 3x squared is going to equal 0. We're going to take out a common factor of x squared, leaving us with x minus 3 inside the bracket. So x squared equals 0 is going to give us that point at the origin, and or x minus 3 equals 0 is going to give us the other root of this curve. So the curve is going to be going through the origin, which we've already plotted, and 3, 0. And if we go back to our Cartesian grid, we can plot on that second root. Now the next thing we want to do is look at the stationary points and their nature. And we do that by differentiating the function. So we've got f of x equals x cubed minus 3x squared. So our derivative of f of x is going to be 3x squared minus 6x. And we equate that to 0 because we know the gradient of stationary points is 0. Then we're going to take out a common factor of 3x, and we're going to equate the 3x to 0, giving us a point of 0, and x minus 2 is going to equal 0, giving us a value of x of 2. Now we need to substitute those back into our original curve. And we already know that when we put x equals 0 in, we're going to get y equals 0. So we've got a stationary point at the origin. And when x equals 2, we get y equals 2 cubed minus 3 times 2 squared. And that gives us a value for y of negative 4. So our other stationary point is at 2, negative 4. And we can plot that stationary point onto our Cartesian grid and label it. And now we need to work out what the nature of our stationary points are. So we've got a stationary point at 0, 0, which is a tangent to our axis. And we've got a stationary point at 2, negative 4. And our derivative of our function was 3x squared minus 6x. So we need to do our nature table to work out the nature of these two stationary points. So we're looking at values of x before 0, between 0 and 2, and then beyond 2. And we're going to inspect the derivative and what the slope or the gradient is going to be. So we know we've got stationary points with a gradient of 0 at 0 and 2. If we consider negative 1, it's going to have a positive gradient. If we consider 1, then it's going to have a negative gradient. And if we consider a value of 3, then it's going to have a positive gradient. So we can see that we've got a maximum stationary point at the origin, and we've got a minimum stationary point at 2, negative 4. So before we can connect all of our points together, we need to consider the behaviour of our curve for large negative and positive values of x. So as x tends to negative infinity, We know that our curve was f of x equals x cubed, which is going to be the main component. So f of x is going to tend to negative infinity 2, because any number that's negative that's cubed is going to be a negative. And as x tends to positive infinity, f of x is going to tend to positive infinity. So now we can go back to our Cartesian grid and connect our points with a smooth curve with a maximum stationary point at 0, 0 and a minimum stationary point at 2, negative 4, going through our roots and labelling the curve at the end with y equals x cubed minus 3x squared. Now in this example we want to sketch the curve y equals x cubed plus 4x squared minus 3x minus 18 and annotate fully. So we want to follow the same procedure. So step 1 is to find our points of intersection with the x and y axes. So we're going to let x equal 0 and y is going to equal 0 cubed plus 4 times 0 squared minus 3 times 0, take away 18, giving us an intercept on our y-axis of 0 and negative 18. And we can plot that onto our Cartesian grid at 0 and negative 18 and make sure that you label it. So now we want to work out the roots of this curve. So that's at y equals 0. So we're going to equate our curve x cubed plus 4x squared minus 3x minus 18 to 0. And we're going to have to use our nested form in order to work out what our first root is. So we've got 1, 4, negative 3 and negative 18. And we're going to try 2. So 1 times 2 is 2, 4 plus 2 is 6, 6 times 2 is 12, negative 3 plus 12 is 9, 9 times 2 is 18, and that gives us our remainder of 0, so we know that x minus 2 is a factor of this curve. So now we need to finish factorising. So we've got x minus 2 upon x squared plus 6x plus 9, and that's going to equal 0. And so factorising that fully, we have x minus 2 upon x plus 3 all squared equals 0. So we need to equate those brackets to 0 to find our roots. So we've got x minus 2 equals 0, giving us x minus 2. So we've got a root at 2, 0. And x plus 3 squared equals 0 gives us a stationary point root at x equals negative 3, 0. And we're going to plot those roots onto our Cartesian grid at 2, 0 and negative 3, 0. Now we need to work out our stationary points, so we need to differentiate our curve, which was x cubed plus 4x squared minus 3x minus 18. So the derivative of f of x, f dash x, is going to be 3x squared plus 8x minus 3. And we're going to equate that to 0 because we know the gradient of our stationary points is 0. And then we're going to work out that our magic number is negative 9. And so we need a positive 9 and a negative 1 to make that 8x. And we're going to substitute that back in. So we've got 3x squared plus 9x minus x minus 3 equals 0. We're going to factorise the first two terms, so 3x upon x plus 3 minus 1 upon x plus 3 equals 0. So our brackets are 3x minus 1 upon x plus 3 equals 0. So to find our stationary points, we've got one stationary point at x equals a third, and we've got another stationary point that we already know about because it's one of our roots at x equals negative 3. So to work out our y value, we're substituting a third into the original curve. So a third cubed plus 4 multiplied by a third squared minus 3 times a third. And we're going to take away 18. So applying BODMAS, we're going to get 1 over 27 plus 4 over 9 minus 1 minus 18. And so at x equals a third, y is going to equal negative 18, and 14/27, giving us a stationary point at a third, -18 and 14/27. Now we already know that at x equals -3, y equals 0, so our other stationary point is at the root -3, 0. And we're going to plot these points onto our Cartesian grid. So we've already got our -3, 0 plotted, and our other point is going to be at a third, -18 and 14/27. So now we need to consider the nature of these stationary points. So our stationary points were at -3, 0 and also at a third, -18 and 14/27. And the derivative of our function was f dash x equals 3x squared plus 8x minus 3. So our nature table, we're going to consider our values of x leading up to -3, between -3 and a third, and then beyond a third. And we're going to consider what happens to the derivative and what the slope or the gradient is going to look like. So we know we've got stationary points at -3 and a third. If we consider -4, then our derivative is going to have a positive value, so the slope is going to go up. If we consider 0, we're going to have a negative value, so our slope is going to go down. And if we consider the value of 1, then our slope is going to go up. So we're going to end up with a maximum stationary point at -3, 0. And we're going to end up with a minimum stationary point at a third, -18 and 14/27. Finally, we need to consider our very large negative and positive values of x. So as x tends to negative infinity, f of x is going to also tend to negative infinity because of that x cubed component. And at x tends to positive infinity, our function of x is also going to tend to positive infinity. So now we need to put our smooth curve. So we've got a maximum turning point at -3, 0, going through our y-intercept of -18, a minimum turning point at a third, -18 and 14/27, going through our root at 2, 0, heading towards positive infinity, and labeling our curve with y equals x cubed plus 4x squared minus 3x minus 18.